Hi students, this is a review of lesson 3.1.1 looking through the Desmos Slides 11 through 22. So make sure you have that up and you're ready to pause it because what you should do is look at the slide and then watch the video. We're going to start with slide 11, so pause and then take a look at this once you try it. So hopefully you tried y to the fifth times y to the second. What we want to do is write that out, expand this expression by writing that first y 5 times y to the fifth times y to the second would be 2 more y's. And if we counted them up, we have 1, 2, 3, 4, 5, 6, 7, and we could rewrite that expression as y to the seventh. Our next slide, 12, is y to the fifth over y to the second. We're going to expand this, writing w 5 times, and w down here twice. Remember, we can use this power of 1 by saying w over w is equal to 1. What am I left with on top? I'm left with 3 more w's. I can always, if there's nothing left on the bottom, remember, we can always put that 1 there because anything times 1 is 1. So w divided by w is 1, w divided by w is 1, and we're left with 3 w's on the top for w to the third power. Here's slide 13. It's x to the second to the fourth power. We're going to call this power to a power eventually. So take a moment and see if you can understand this. All right, hopefully you tried that out. Hit pause, try it out. What we have on the inside is x times x. All right, that's to the fourth power. Well, that means we have 4 of these expressions: x times x, x times x, x times x, and x times x. Well, we can count those up now, right? 1, 2, 3, 4, 5, 6, 7, 8, and we get x to the 8th. Do you notice anything when you look at 2 to the fourth power and how we get to 8? We'll look at that in class on Tuesday. Here we are on slide 14. This says x to the 10th power times x to the 12th power. Can you count how many x's there will be total without writing it out? We can write it out, but it starts to get a little long and overwhelming. So if we have 10 x's, and I'll do it, if I don't get sloppy first. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then this one is 12 more, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Count those up and you have a total of, that's right, 22. Did you get it? Now we're looking at slide 15. Take a moment, try this out for yourself, and then hit play and come back and let's take a look at it. Notice the numerator here is 13p to the fourth, q to the fifth. The denominator is p squared times q squared. It's going to be helpful right now to expand this. On the top we have 13 times p times p times p times p times q times q times q times q times q. Notice 4 p's, 5 q's, and I get that from the exponents. On the denominator we end up with 2 p's and 2 q's. Now I wrote them with the q's on top of each other and the p's on top of each other because this is how I like to do it. I know p divided by 1p is 1. This p divided by this p is 1. So we can remove those from this expression because they are equal to 1. Right? Q over q is 1. Q over q is 1. And so if I look at this again, what we have here on top, the numerator is 13 times p times p times q times q times q. So I'm going to write 13 times P times P times Q times Q times Q. Now, the denominator here, we have P, P, Q, Q, but those all equaled 1. So I really am left with no variables on the bottom. But do I put a 0 here? No, because these equal 1. And remember, if they equal 1, we really end up having 1 times 1 times 1 times 1 in my denominator. So this whole thing is over 1. All right? And so I'm going to squish them back together and rewrite this by saying 13. P times P is P squared. Q times Q times Q is Q to the third. And so there's our final answer. How'd you do? So this is slide 16. And notice we have a fraction inside these parentheses, and it's all being taken to the third power. So that third power means we have 3 sets of what's inside being multiplied by each other. So we're going to do this first by saying we have 3 of these sets. So I have x squared over y times x squared over y times x squared over y. Now we can expand what's inside first, or we can expand it now. Hopefully you can see 2 ways of doing this. So inside of each of these I have x times x, so I'm going to write that. So on top I have x times x. On this top I have x times x. And this numerator I have x times x. All right? And on the bottom for each of these we have y, y, and y. Now we can leave these parentheses in there, but that's just another way of saying these quantities are being multiplied by each other. And so when we look at the numerators across, we end up with how many x's? 1, 2, 3, 4, 5, 6. So we write that as x to the 6th. In the denominator, we have y times y times y, which is y to the 3rd. X's and y's, we can't use those to eliminate, right? They're not the same, they're different variables, and so this is our final simplified expression. See, x to the 2nd to the 3rd power, we get a 6. Y to the 3rd power, we get a 3. Hopefully that's making your brain see a pattern. In this one we have 2 numerators, right? Or, 2 coefficients. We have 5 and 2. So we have some constants in there. All right, take a moment, pause this, and see what you have. All right, hopefully you tried this on your own. That's the best way to learn. So make sure you pause, try it on your own, and then come back. I'm going to expand these. I have 5 times h times 2 and times h 24 times. Oh man. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, I just squeezed it in there. So let's just start with the h's. How many do I have total? I have 1 here, and I have 24 here. 1 plus 24 is 25 h's. So I have h to the 25th. Let me make that a little cleaner. Sloppy 5. Now I have 5 and 2. Notice I'm multiplying them. So we can just take those constants, right, and we can multiply 5 times 2, and we end up with 10. So I have 10 h to the 25th. Review that one if you need to. Here we are on slide 18. Pause, come back, take a look now. 10 times m to the 30th, and on the bottom we have 2 times m to the 8th. I'm not writing this out 30 times. I want you to think about this. If I have 10 divided by 2, that's 5. If I have m to the 30th divided by m to the 8th, I will have 30 m's on top, 8 m's on the bottom. I can get rid of 8 of these 30. So I'm thinking m to the 30th minus 8 gives me m to the 22nd. And so I have 5m to the 22nd. we're going to talk about what this rule is called in class on Tuesday. All right, here's slide, let's see, 20. This one's a little different, and so let's expand this just to see what's happening here. I have 24 times h times g times g. On the bottom, I have 3 times h times g times g times g times g times g times g times g. 1, 2, 3, 4, 5, 6, 7. I need 2 more for 9 of those. Now, maybe you're noticing I'm lining up the variables I know are the same on top of each other, because remember, the power of 1 here, h divided by h is 1, g divided by g is 1, g divided by g is 1, but I don't have any more g's on top for these g's in the denominator. So we're going to have to keep those around. Here I have 24 over 3. What is 24 divided by 3? 24 divided by 3 is 8. So where do you think that should go? 24 divided by 3 is 8. Should that be a numerator? Should that be a denominator? Well, it is a whole number, and so we could write it in front of our fraction, 8, and then on top of the fraction we would have 1, since nothing else is left there, and on the denominator, since we use the 3, we're left with 1, 2, 3, 4, 5, 6, 7 g's. So you could write it like this, but I prefer that we just leave it as this weird mixed fraction right now, 8 over g to the 7th. Okay? Either one's correct, 8 times 1 over g to the 7th, or 8 over g to the 7th. Remember, some of these are going to take more time to figure out. Here we are on slide 21. Here we have a fraction with a power to a power. And so what we know is inside of this, we have 4 sets of what's inside, because this whole thing is taken to the 4th power. So pause, try that out. All right, hopefully you tried it, and I think this is the best way to do this. So m to the 3rd over m to the 10th. How many times? I hope you said 4 times in your head. And so we're going to write this out 4 times. Now, we could write m times m times m 3 times, 3 more times, 3 more times, 3 more times. And we could write those all out. But can you count by 3s? Yeah, we have 3 m's here, 3, 3, 3, for a total of 12. 3 plus 3 plus 3 plus 3 is 12. On the bottom, the same thing. We have 10 m's times each other here, with 10 more, 10 more, 10 more, for a total of 40. Well now, do we have more m's on top or on the bottom? We have more on the bottom. And so if I wrote out 40 of these, and I wrote out 12 of these, we'd be able to have m over m 12 times, right? M over m 12 times, and be left over with some on the bottom. So how do we figure that out? Well, it's be 40 minus 12. So I have m with 40 minus 12 is going to give me m to the 28th on the bottom. All right? Then, since I got rid of all those m's on top by dividing m over m, I'm left with 1 on top. So we have one last one to look at, and I'm running out of time. So we're just going to do slide 22 here quickly. What you can see here is we have w to the 4th, p, and w to the 3rd. The thing you have to remember here is you can't combine variables that are not the same. And so we end up with w 4 times, p once, w 3 times. So when we squish them back together, we get w to the 7th times p. We write that as w7p. Hopefully this was helpful. You might have to watch it multiple times to catch back up. Look at the slides, try them out. Slide 23 has all the answers there for you to check, and you can keep moving on as you grow. New chapter, new way to focus. Hopefully this was helpful. Email Mr. Winter or your teacher if you have any other questions.